March the 4th, 1942. Somewhere above the Black Pacific, at an altitude where the air burns cold and thin, two enormous flying boats drone through cloud that stretches unbroken to every horizon. Each aircraft carries a wingspan wider than a modern airliner, for engines laboring in the darkness, and a crew straining to find a target they cannot see. Below them, hidden beneath the weather, lies Pearl Harbor, the American naval base attacked less than 3 months earlier. These aircraft have flown further than any bomber should reasonably be able to fly, refueled not at a friendly airfield, but from submarines waiting at a remote, uninhabited atoll far out in open ocean. Nobody watching from the ground below will ever see them arrive. Nobody in Washington yet understands that Japan possesses an aircraft capable of this. What began as a routine reconnaissance requirement has become something else entirely, an attempt to strike the heart of American naval power a second time, using a machine so large, so capable, and so quietly extraordinary that Allied intelligence has barely begun to grasp what it can do. The question the mission raises will outlast the mission itself. How had Japan built a flying boat capable of reaching Hawaii and returning, when no other nation had produced anything comparable? The answer lay years in the past, in a design problem that seemed, at the time, almost impossible to solve. By the mid-1930s, the Imperial Japanese Navy faced a strategic dilemma rooted in geography. Japan's planners anticipated a war fought across the vast distances of the Pacific, where island garrisons, shipping lanes, and enemy fleets might lie thousands of miles from the nearest Japanese airfield. Conventional land-based aircraft, however capable, were bound by the availability of runways, and in the open ocean there were none. Existing Japanese flying boats, chiefly the Kawanishi H8K, had extended range considerably, but naval planners wanted more. An aircraft that could patrol deep into enemy waters, shadow fleet movements for hour after hour, and, if necessary, strike distant targets without needing to refuel on land at all. American naval doctrine assumed the Pacific's distances offered a natural defense. Japanese naval planners set out to remove that assumption. The requirement issued to Kawanishi Aircraft Company in 1938 asked for something few engineers elsewhere would have attempted: a 4-engine flying boat combining exceptional range with genuine speed and heavy defensive firepower, able to survive the fighters it would inevitably encounter while loitering far from any friendly base. Existing designs, Japanese and foreign alike, sacrificed one quality for another. Long-range flying boats tended to be slow and vulnerable. Fast aircraft carried too little fuel. Kawanishi's engineers, led by designer Shizuo Kikuhara, understood that meeting the Navy's demands would require solving problems in hull design, aerodynamics, and structural weight that no manufacturer had fully resolved. What emerged from that challenge would take nearly 3 years to perfect, and its earliest attempts very nearly failed outright. Kikuhara's team began with the H-6K's broad experience of long-range flight, but the new aircraft, designated H-8K, required an almost entirely fresh approach to the hull. Early testing in early 1941 revealed a serious flaw. The aircraft porpoised dangerously across the water during takeoff, its hull striking the surface in a series of violent bounces that risked structural damage and made operation from anything but calm water hazardous. Engineers redesigned the hull's planing bottom, adjusting its steps and contours until the aircraft could lift cleanly from open water even in moderate swell, a problem that had defeated earlier Japanese and foreign designs alike. The finished aircraft, which entered limited service in 1941 and reached full operational readiness in 1942, was formidable by any standard. 4 Mitsubishi Kase radial engines, each producing in the region of 1,530 horsepower, drove the H-8K to a top speed of around 290 miles per hour, remarkably fast for an aircraft weighing over 32 tons fully loaded. Its range exceeded 4,000 nautical miles, allowing missions that no land-based bomber of the era could contemplate, and its defensive armament, eventually including 5 20mm cannon alongside several machine guns, made it a genuinely dangerous opponent for intercepting fighters rather than easy prey. The aircraft could carry bombs or torpedoes or be configured to carry passengers and cargo across the vast distances of the Japanese-controlled Pacific. None of this came without cost. The H-8K remained a complex, expensive aircraft to build, requiring skilled labor and substantial materials at a time when Japan's industrial capacity was already stretched thin. Kawanishi's factories at Konin, near Kobe, would ultimately produce only around 167 of the type across the entire war, a modest number reflecting both the aircraft's complexity and the mounting pressure on Japanese industry as the conflict widened. Weight was another persistent challenge. Every addition of armor or firepower reduced the fuel load available for the long patrols the aircraft was designed to fly, and engineers spent much of the design process balancing protection against the endurance the Navy demanded. What resulted, nonetheless, was widely regarded by Allied airmen who later encountered it as the finest flying boat operated by any nation during the war, a judgment borne out by the aircraft's operational record once it entered combat. That record began, most famously, with a mission over Hawaii in March 1942, an operation the Japanese Navy designated Operation K. Two H-8Ks, flying from the Marshall Islands, refueled from submarines waiting at French frigate shoals, a remote atoll roughly 500 miles from Oahu, before continuing towards Pearl Harbor under cover of darkness. The mission demonstrated the aircraft's extraordinary range in practice rather than theory, a round trip of thousands of miles that no other nation's flying boat could have attempted. Yet the operation itself achieved little. Thick cloud obscured the target. American searchlights probed the darkness without finding the aircraft, and the bombs that fell landed harmlessly on a mountainside and in the sea, causing no meaningful damage. Contemporary American reports treated the raid chiefly as a curiosity, evidence that Japanese aircraft had reached Hawaii rather than proof of any serious threat. The mission's true significance lay not in what it destroyed, but in what it revealed about the aircraft's capability. A capability the H-8K would go on to demonstrate repeatedly in reconnaissance and patrol duties across the Pacific for the remainder of the war. If you're enjoying this journey through history, subscribing genuinely helps us continue bringing remarkable, true stories like this to the channel. Set against its Allied counterparts, the H-8K's advantages become clearer still. The American PBY Catalina, ubiquitous across the Pacific, offered reliability and reasonable range but could not match the Japanese aircraft speed, and its defensive armament was comparatively light. The larger American PBM Mariner came closer in performance but entered widespread service later and never matched the H-8K's combination of range and speed. Britain's Short Sunderland, built for the different demands of the Atlantic and coastal patrol, prioritized endurance and defensive firepower over outright speed, reflecting a distinct set of operational requirements rather than a simple deficiency. None of these aircraft have been designed to solve precisely the same problem the H-8K addressed, the need to patrol and strike across distances unique to the Pacific theater, and comparisons should account for that difference rather than crown a single winner. Where the H-8K held a clear and measurable edge was in the specific combination Japanese naval doctrine had demanded. Few flying boats of any nation could outrun it, and fewer still could match its range while carrying comparable defensive firepower. The wider historical impact of the H-8K, though, remained narrower than its technical brilliance might suggest. It never altered the Pacific War's broader trajectory. America's growing industrial and numerical superiority overwhelmed Japan regardless of individual aircraft quality. Its influence was operational rather than strategic, providing valuable long-range reconnaissance that helped Japanese commanders track Allied fleet movements during the war's early and middle years, and its rarity meant it could never be produced in numbers sufficient to shape outcomes on its own. Historians generally agree that the H-8K represented a genuine engineering achievement without ever becoming a war-winning weapon, a distinction the aircraft shares with numerous technically impressive systems fielded by all combatants. Today, remarkably, a single H-8K survives. Recovered by American forces after the war and later returned to Japan, it is preserved at the Kanoya Naval Air Base Museum, the last intact example of an aircraft that once demonstrated Japan's capacity to reach further across the Pacific than any other nation believed possible. Return, then, to that night above the clouds in March 1942, two aircraft searching for a target hidden beneath whether they could not overcome. The mission failed in its immediate purpose, yet it answered a question Allied planners had not thought to ask: whether an aircraft existed capable of striking so far from any friendly shore. It did, and the men who built it had solved a problem that had defeated engineers elsewhere, producing a flying boat that combined range, speed, and firepower in a way no rival aircraft matched. The crews who flew it that night could not have known how the war would end, nor how briefly their aircraft's advantages would matter against the industrial weight gathering against them. What they achieved was real nonetheless. Proof that ingenuity, however impressive, cannot alone determine the outcome of a war, but that it can, for a moment, extend a nation's reach further than anyone believed possible. The clouds that hid Pearl Harbor that night have long since cleared, but the aircraft that flew above them remains a quiet reminder of how far human engineering can travel before history decides where it will land.